We got Timo, who comes from very far to do this presentation, and he'd like to get started. So I'm going to give it another few seconds, but please move down. Or if you stay upstairs, stay quiet. So we got like 2 more presentations to go, and a panel discussion, and then we at the point of entertainment. The next presentation is we're very impressed to have Red Hat here. Red Hat has also been like a very generous sponsor of this event, and as you guys know, their technology in this environment is pretty mainline. Cannot be ignored, continues to grow at a rapid rate, in not only the service provider community, but nowadays, in most communities. So I take pleasure in inviting Timo Jokiao. He's the Chief Technologist for Telecom, Media and Entertainment for Red Hat in Europe, Middle East and Africa. Timo, thank you very much.
Thank you. All right, I'm really happy to be here to talk on behalf of Red Hat, and as said, I'm Chief Technologist at Red Hat EMEA Telecom, Media and Entertainment division, focusing on 5G core and Open RAN, of course, seriously right now. And I will talk about same themes as we have heard already today, like consistent cloud platform all over the places and importance of automation. But of course, we are a platform vendor, so I'm looking at that domain from the platform point of view. Now, it's still a little bit surprise to many people that Red Hat is a player in telco networking and now in radio access network specifically. But we are, and my main idea today is to explain how we fit into Open RAN ecosystem and what we do, and also importantly what we don't do. So these are the topics for today. It's 20 minutes. It's a challenging, complex topic, so it's going to be high-level presentation only, unfortunately. But let's see what we can get out of this. But I always need to start with this standard Red Hat slide, which describes our development model, which is unique. We call it open source upstream first. And what that means, quickly spoken, is that 75–80% of our software developers, they work directly in the middle of this slide, the red bubble, open source project, not Red Hat internal, but out there, public project, together with our customers and our partners, and very much with our competitors, which is interesting. But that's our model, has been for a long time, and it has turned out to be very successful. Now, why we call it upstream first, it means that we can commit to a feature in our product only after the upstream community leaders have agreed that this thing will be in the next community release. So we don't kind of control the roadmaps tightly, which is the normal way in telecom industry at least, but we don't. But what that means is that we don't create anything Red Hat specific, Red Hat or customer specific. It's all based on open source upstream project, and there's a big development and maintenance community behind all of our products, which are on both sides of this slide, which are the supported products. Now, we have the similar idea as we heard from Rakuten, as we heard from Juniper. We call it the Open Telco Cloud, consistent, high-quality, common cloud platform all over the places. Like on the right-hand side is an IT, more like IT applications, OSS, BSS, going towards core network, and then on the left-hand side, access network, radio access specifically, as we call it. And we are using the same platform in all of these places with with high configurability, because the requirement of the platform is different when you are on the far edge or when you are on the core or when you are on the IT side. But we have one product, highly configurable, and so far it's been working really well. Now, quickly recapping of what we already heard today. So left-hand side of this slide is the 3GPP spec. It's called disaggregated base station or functional split or whatever you call it. It's kind of a vertical disaggregation. And the right-hand side is horizontal disaggregation, so separation of hardware and software using cloud technologies and cloud platforms, hosting the DU and CU workloads specifically. So 3GPP made an interesting decision already some time ago when they started to standardize 5G as a whole. They started to call for cloud nativeness, containers, microservices, and all these things. And that's a perfect fit for multi-vendor network deployment, and very perfect fit for Red Hat, because that's what we do. And O-RAN Alliance started to build on top of what 3GPP did, complementing the specifications which were not done by 3GPP. For example, one of the most important is the open front haul between the radio and the DU. That's O-RAN Alliance work. And Telecom Infra Project is the third one playing in this domain, and they have, right now they have, I think, 17 or 18 Telecom Infra Project community labs globally, doing interoperability testing of not just Open RAN components, but also the 5G core network components. It's a very, very important exercise. We are part of a few of those, like in Indonesia and Philippines and I think Brazil as well. But there is many of those. Now, this is one of my favorite topics, which is kind of interesting. I'm not going to read the text, but if you look at the Venn diagram on the right-hand side, that kind of describes this Open RAN or disaggregated RAN domain. And it's very confusing sometimes, or all the time it's very confusing. You know, let's take 2 examples. There is an Open RAN which has a space in between, so 2 words, which is a big bubble. And then there's an Open RAN without space in between, the small bubble. And that Open RAN is specifically Telecom Infra Project Open RAN working group without space. So this is highly confusing. And then, of course, under the Open RAN, the big bubble umbrella, there is an O-RAN Alliance doing its great work, architecture work, and specification work. And then there is even vRAN, which doesn't even necessarily fall under Open RAN. So vRAN is the same disaggregated model, but virtualizing or containerizing DU and CU, and has no open interfaces. And those implementations are existing even live networks today. But eventually, and then of course there's a CRAN, which can be called Cloud Native RAN, which is a subset of vRAN. So this is confusing. Now, I believe industry's goal in this play is O-RAN Alliance compliant RAN eventually, which actually is not possible today because of specifications are not ready. But that's the industry's goal. Now this is how it looks like the disaggregated model by 3GPP, having a radio unit, having a distributed unit, and then centralized unit, control plane and user plane, and the DU/CU hosted by cloud platform OpenShift in our case. Those boxes should be very bright red, but they are not, unfortunately, because we are red. So this is model, and this particular diagram is very typically single RAN vendor implementation. There is no open front haul. Of course, there is a mid-hole specification from 3GPP, but I haven't seen any implementation or deployment of disaggregated RAN where CU and DU are coming from different vendors. It is possible because there is a 3GPP standard, but I haven't seen any. So this is typically single RAN vendor implementation, still having a third-party cloud platform like Red Hat OpenShift. And the next slide is just adding one thing, which I mentioned earlier, is the O-RAN Alliance Open Fronthaul specification between RU and DU, which is probably the most important interface as we speak today, because that allows service providers to pick a radio unit separate from DU. And there are quite a few radio units already which are Open Fronthaul compliant from well-known vendors. I think NEC in Japan included. Airspan is one, and many others, Bicells. So this is a potentially multi-RAN vendor model, but it's still not O-RAN Alliance compliant. It just adds one interface, which is the Open Fronthaul. And the next one, high-level picture to add one more dimension on O-RAN Alliance, which is the O-Cloud. They call the cloud platform O-Cloud with their nomenclature, and that is connected to service management and orchestration and other places. So this is how it looks on very, very high level. Then I have a more detailed diagram on the same thing. So complete O-RAN Alliance diagram. So the block diagram is from their white paper, and what I have done is I have added those dashed line. No, they are not dashed line anymore, but you know, all these boxes I have added myself on top of the O-RAN Alliance diagram, and it shows that you can do 4G and 5G radio line with the same concept, which O-RAN Alliance and 3GPP support, both of them. And then O-Cloud is supposed to host RU, no, not RU, RU is outside, DU, CU, and near real-time RAN intelligent controller, and then service management and orchestration on upper part. And those two boxes are where we play in. Now, I think this is the appropriate place to mention a couple of things. First thing is that we as Red Hat, we have no applications for any purpose. We don't develop applications, not for IT, not for telco, not for RAN, not for edge, we just don't. We are a pure open source software platform and tools vendor, you know, platform specifically, and then of course automation tools, which have been discussed today many times. We do have an end-to-end automation capabilities, even in telco networks, 5G and Open RAN included. And the automation tools are, of course, used in IT side very heavily as well. So we don't have applications, which means that the ecosystem and our partnership with other people is extremely important, because alone we cannot build anything. We need partners, application partners and hardware partners, of course, and system integration partners as well. We cannot even do that. We are purely 100% open source company for platforms. Now, I'm going to go through these very quickly. So this slide is specific to distributed unit. You know, centralized unit is kind of easy from a cloud platform point of view. Distributed unit is not that easy. It's been done, of course, but these are the three main things we had to do, had to develop into our Kubernetes-based container platform, OpenShift, real-time execution environment. Most of the RAN vendors need real-time execution capabilities. Not everybody, but most of the people do need that. And timing and synchronization is interesting, because O-RAN Alliance made a decision already some time ago that in multi-vendor RAN implementation or deployment, somebody has to be responsible of timing and synchronization, and that somebody is very logically cloud platform. So what we have done is to take the timing information from the satellites, and with the precision time protocol, we distribute the timing information to distributed unit and radio unit. So those guys are then in sync between themselves. So that's all done, and we've been presenting our work and measurements in international conferences quite a few times, and we will present again in November in Germany. And the idea in November is to add SYNC-E in addition to precision time protocol. So we don't have SYNC-E yet, but it's going to be there towards the end of this year. And hardware acceleration for forward error correction and other purposes to talk to radio unit. It can be an FPGA like Intel N3000 FPGA is the most used today. It can be also GPU or anything else. And we don't need hardware acceleration ourselves, but we need to offer access to the hardware accelerators to DU workload through the cloud platform. So 3 main things we had to do, and it's all done. And again, SYNC-E is coming later. Then there are a bunch of others which I don't go through too much details. Now this is my view on what we saw from Rakuten and what we saw from Juniper. Common platform all over the places, which can be multiple clusters as I've drawn here in this diagram, but it's the same platform. And on the radio side, 3 different obvious deployment models on the left-hand side of the slide, and then other applications towards the right. Now, when you have the common cloud platform all over the places, that really enables and makes it way easier to apply automation end-to-end when you have the same environment in all of the places. And the other thing which the common consistent cloud platform enables is to make it easier to relocate application from place to place if there is a need for that. And if you had a different environment, that would be very difficult, but with a common cloud platform, you can do that. Now, security, we are of course focusing on platform security, starting from host Linux. We use Red Hat Enterprise Linux Core OS, which is container optimized Linux distribution with high security features built into the Linux itself. And then the whole stack, of course, have to follow the security standards, which I have on the left-hand side. Many organizations, we try to comply. Actually, we have to comply to many of these security standards. And then there is a list of 10 topics on the security side, but that's highly important. And there has been claims in the industry, not recently, but year and a half ago, that Open RAN cannot be made secure, which we completely disagree. It can. It's maybe even easier because you have smaller entities, not just a big monolithic thing, but you have smaller entities and you can secure the entities within themselves. Now, this is another thing I'm not going to have time to go through, but we are working on zero-touch provisioning using GitOps model, meaning that everything is treated as a code, like configurations and software itself, and everything is stored in the Git repository, where from Git workflow model you can pull the single source of truth towards the network with fallback capabilities and all these things. This is highly important thing, and we are pushing that, and not just us, but many other people as well are pushing the Git model to telco networks. Now, a little bit on the ecosystem. So this is how the open source environment is kind of mapped into telco networks. or telecom industry vertical. So on the left-hand side, there are a bunch of organizations, not a complete list, but just an example. And these organizations are working to specify architectures and interfaces in telco networking. And we are part of most of those, many of those, probably most of those. And what we do, we take the industry organization requirement or whatever they produce. Let's talk about requirement. We take those and then we translate the requirements into the language which the open source developers hopefully understand, which is the middle part. So we push them to the open source communities, and then once things are developed and looks good, then we take again the open source model or distribution and build a product out of it, and then we go back and start again. So this is the open source environment, and this is our RAN ecosystem. Probably again not quite complete, it's never complete. But as you can see here, we need partners on all of these segments. You know, hardware partners, you know, server vendors, technology vendor, hardware technology vendors, and then of course we are working with pretty much every RAN vendor to validate their DU and CU on Red Hat OpenShift. So we've been doing that for quite a while, you know, NEC included. We are doing that in Japan. Then system integration, as I said, we are not built for that, and we need those guys and many others. And not surprisingly, we are also building a lab. We heard that NEC is going to have a lab here in Johannesburg, or is there already. We are building our lab in Massachusetts, which is 10 miles north from Boston, very close to our big R&D center in that area. It's not quite there yet, but similar idea that we will be able to interoperability testing work with our partners. And it's not just RAN, it's also core, but we do have a walk-in Faraday room and everything to get radio units in there, so no surprise. And then just quickly showing again another view of the common telco cloud. Starting from left-hand side is the radio or edge, and then we go to private cloud, on-premises cloud, and we can even use Red Hat OpenShift on hyperscaler public cloud to give the application developers and end customers flexibility to move their applications wherever they want based on the requirement, even public cloud, if the application is fit for public cloud. And that's the OpenShift, and I'm not going to talk about it. It's too much for this presentation, but that was my story. So I'm happy that you listened to me, and well, good.
Thank you very much. Thank you, Timo.
Thank you.
Thank you very much.